explain about the Mason's problem, which is the easiest topic. You can grab easily marks here. So this is the problem. So as we know, the transfer function of the Mason's gain formula is nothing but output by input. So it is given by Mason's gain formula is nothing but summation del k pk into delta k divided by delta. So step 1 is nothing but number of forward path, that is denoted by k. So it tells in how many ways we can reach the input to output. So one path is that from R to C, means input to output, we can reach straight line like this. You can see from R to C, and in another way we can go from R, from this node to this node, then from this second node to this node with a gain of G6, which is shown here. See this one, we can go in this path or this path, but we cannot go in this path because as you can see the direction. See here, see the direction. So this and this, which is net minus h1, minus h2, and minus h3, these three are in the negative or opposite direction, you can see. So it's gain, it's not gain, but it is feedback is in negative direction, but we are traveling in here from this direction, from here to here. So consider this. So opposite direction you cannot consider. So from that you can write, so you can write like this. So then we can it is denoted by p1. P1 can be written as g1, g2, g3, g4, g5. It is nothing but multiply all these gains, 1 into g1 into g2 into g3, g4, g5 into 1. So you'll get p1 denoted by p1. This first way you can write, or you can go from input to output. So second way we can travel is that in this way, from here input to output. So here also same, you can denote it by p2, and you just multiply its gain. G denotes the gain of this node. This round circular shaped two balls represent a node. This is nothing but a node. This is represent the gain. 1 is the gain here. Here G6 is the gain. Here G4 is the gain. So on. So number of forward path, that is denoted by k. So in two ways you can go right here. So k is equal to 2. See. So we can rewrite this formula as this Mason's formula as P1 del 1 delta 1, P2 delta 2, plus so on Pn delta n divided by delta. So here we have k value 2. So this is the first step. Now second step is nothing but individual loop gains. So individual loop gains is nothing but this one. You can see here this minus h1, minus h2, and minus h3. So these are in opposite direction. You need to take that loops, okay, which are in opposite direction. So you write separately here like this, and here also you denote it by L1, loop 1. Loop 1 means here this is loop 1. So it's gain into its feedback. So minus g2 into minus h1 minus g2 h1. So L2 is also same, do the same, multiply its gain and feedback. So similar, but here so as you can see we have take minus h1, minus h2, and minus h3, but you cannot take this one because it is opposite to our direction. Now in second step, it is nothing but individual of loop gains. We are going from here, from output to input we are going. So direction is in this way. So this is in the opposite direction, G6. So in opposite direction you cannot take. So these are the three individual loops, L1, L2, L3. Okay, next step 3 is gain of non-touching loops. So gain of non-touching loops means, see here, if you consider this is one loop 1 and loop 2 and loop 3. So this loop 1 node is not touching the node of the loop 3. You can see there is a difference. So this node and this node is not touching. Okay, there is a gap. So and this is, from this we can write the L13 equation, loop 1 and 3 equation. And again you can see loop 2 and loop 3 are not touching. Their nodes are not touching, no. So you can write L23. But you can see this loop 1 and loop 2 are touching, so you cannot write this node. And loop 2 and loop if you consider 4, these are also touching, so you cannot take it. Okay, so that is given by equation. From this you can write, so L1 G2 H1, L1 and L3. So L1 and L3 you can write G2 H1 and minus G5 and H3. You need to just multiply here, nothing, that's it. And L2 3. So you get these equations. Next step 4 is to find delta and delta k. So delta is found by using this formula, 1 minus sum of individual loop gains plus sum of two non-touching loops, that is nothing but this one, minus sum of 3 non-touching loops. If further it is given, consider it. Here it is 0, sum of 3 non-touching loops is 0. So consider this. So sign is nothing but inverted sign. First negative, positive, negative, and next positive. So you just add the values here, like sum of individual loop gains means this L1, L2, L3. You just make the summation of it and write here. And sum of non-touching loops means this one, L13 and L23, and this term is 0 here. So you will get the delta equation. By solving this, you will get the delta equation. Now let's find the delta k. So we found that we have two forward path, that is nothing but two ways you can travel input to output, that is k is equal to 2. So delta 1. So for delta k, you need to find delta 1. So delta 1, how will you find? Take the first forward path, that is p1. Okay, this is first forward path p1. Okay, p1 for take first forward path. There you can see if all loops are touching the forward path, then delta 1 equal to 1. If all loops are touching the forward path, then delta 1 equal to 1. See, if all paths are touching the forward path, if all loops are touching the forward path, then delta equal to 1. So here all paths or forward paths are touching these loops. So you can see here it is touching, here it is touching, here it is touching. So then delta 1 equal to 1. Now in delta 2, what it says, it is also similar. Now see the second forward path, that is p2. There check if all loops are touching forward path or no. So in second forward path, what happens here? So in this direction. So here this forward path is touching, and this all are touching, but you can see here from this node with the minus g2 gain. So this is not touching the g6, this gain for this one node. This loop is not touching this one. So delta 1 can be delta 2 can be written as, so delta 2 can be written as 1 minus gain of the non-touching loops. Gain of the non-touching loops is not, see here middle it was like this gain with g2 and minus h1 feedback. This is not touching, so g2 into minus h1. So you can write this. So gain of the non-touching loops is nothing but g2 into minus h1. You put here, this is the formula, and substitute here, you'll get this equation. So delta 2 you got. Now substitute all this in our modified equation, p1 del 1 plus p2 del 2 divided by delta. So put here and just add it and simplify here, and you'll get the solution. This is a final solution of the Mason's problem.